Alright, today we're going to talk about things called inequalities. So basically, what does that mean? Yeah, they're not equal to each other. So, if two numbers are not equal to each other, what are your other two possibilities? Then one number is greater than the other one, or that number is less than the other one. Would you agree? Alright, so those you basically have three situations. You have either the two numbers x and y are equal to each other, right? Or you have x is what? Greater than y, or you have x is what? Less than y. Those are your only possibilities, aren't there, if you're comparing two numbers together? Would you agree with that? Yeah, I can't think of any others. I had a book that they used to call this the Trichotomy Axiom. Alright, so trichotomy. I don't think this book uses this word. Well, tri meaning what? Three. So what's wrong with that? What's wrong with big words? There's only so many. There's only so many little words, right? You gotta have some big words in there, right? Don't be afraid of that. Embrace the big words, okay? Embrace them. That's correct. All right, so I'm not going to make you worry about it. Trichotomy. It just means it's basically there's three things that are true about this. Either two numbers are equal to each other, one is greater than the other, or one is less than the other. Right? Those are your three situations. So try to keep that in mind right there. We know about the inequality symbols, don't we? Okay, greater than. When I don't know, when you're a little kid, you learn. What do you learn? The alligator eats the big one, or something like that. I don't know. But look. Here's what I show people. Let's do it with these straight lines. I didn't really intend to go through this, but I will anyway. That's an equal sign. Agreed? Alright, so that's an equal sign. Agreed? Okay, thank you. So, look at the distance between here and here and here and here. They're the same, aren't they? So that's equal. So, but what if I do this? What if I rotate it? Look what I did to the distances between. Well, it's not exactly. Let me just. Sorry. Okay. So what if I did that? Look at the distance between them now. This is what? Less, and this is greater than what it was before, right? So this, okay, x is what? Less than what? Y. You get it? If you go to the other way, you can actually read these from right to left, can't you? All right. So you could also say what? Y is greater than x, right? And so that's, you will have to do that once in a while. It will be nice to read them right to left. Y is, for instance, if I said x is greater than 3, what's another way to say this? Well, 3 must be what? Less than what? X, right? Okay, would you agree? It means the same exact thing. If x is bigger than 3, then 3 is less than x. For instance, let's stick a number in here that is greater than 3. 5. 5 is greater than 3. Agreed? So you could also say what? That 3 is less than 5. Doesn't that say the same thing? Absolutely. All right. I just want you to get straight on the inequality symbols. I don't want to take anything for granted here, or assume anything. So there you go. Well, basically, when we're solving equations, actually these aren't equations anymore. They're inequalities. They're not equations, because an equation means what? The two sides are equal to each other. This time we're going to have two sides that are not equal to each other. One side is less than the other side, or one side is bigger than the other side. Okay? So here's an example. We'll go straight from the example. Now what you're going to do, and this example does both things that I'm going to describe for you here. Okay, that's a greater than. That's not the greatest, it's not the best greater than symbol in the world. Let's try to make it a little bit. It's no different than what I had. We'll keep it. I guess I'm not making them any better. So here we go. If I wanted you to solve for this, then you would solve for it just like you normally would, just a regular equation, right? With one exception. Okay, the one exception is that when you have to multiply or divide something by a negative number, then you change the inequality. Let's just, before we do this, let's just kind of go through and show you why. So let's do this. Actually, let's not put equals, sorry. Let's put greater than. Let's just do this without any multiplication or division. So what would I do? I would subtract 3 from both sides, correct? Starting really elementary here. So x should be greater than what? 4. So what we can do is we can put numbers in to see if it satisfies that inequality right there. So pick a number greater than 4. 5, okay, put in 5. 5 plus 3 is 8. Is 8 greater than 7? Yeah. Pick a number that's not greater than 4. 2. So put a 2 in here. 2 plus 3 is 5. Is 5 greater than 7? No. 5 is not bigger than 7. Okay. All right. 5 is not greater than 7. So only the numbers that are greater than 4 will work for this. Agreed? Let's do another one. Let's go 3x equals 15. I'm sorry. I keep putting equals there. I'm so used to equals. Let's put greater than. We could put less than if we wanted to, but I'm just going to stick with greater than. So what would you do? If this was a regular equation, you would just divide by what? 3. So I get x is greater than what? 5. So try some numbers. Remember, we want to put it back into the original inequality. 6. Put a 6 in here. 3 times 6 is 18. Is 18 greater than 15? Sure it is. Let's pick a number that's not greater than 5. So that should not work. 4. Put 3 times 4 is 12. Is 12 greater than 15? No, it's not. So numbers that are less than 5 aren't going to work, but all the numbers that are bigger than 5 will always make that thing work. Agreed? Now, let's do this. Let's change this up just a little bit. What if I went negative 3x is greater than 15? Well, what would I divide by? A negative 3. Now watch, I'm going to show you something that you don't do. This is wrong. My next step is wrong. Okay? So remember that. So let's try this. A lot of people would say, oh, we just do what we always do, right? You just, no big deal. But let's see if this works into our original inequality right there. So let's try, pick a number that's greater than negative 5. Negative 4. Put a negative 4 in here. Negative 3 times negative 4 is what? Positive 12. Is positive 12 greater than 15? No, it's not. So people look at this and they're like, well, wait a minute, that doesn't work. Well, you're right, it doesn't work. Let's pick a number that's less than negative 5. Give me an easy one, less than negative 5. Negative 6. Negative 3 times negative 6 is what? Positive 18. Is 18 greater than 15? Yes, it is. So it's actually the other way around, isn't it? All the stuff that's greater than negative 5 doesn't work, and all the stuff that's less than negative 5, what? Does work. So guess what we're going to do to that inequality? We're going to change the inequality. Okay? So instead of greater than, what are we going to do? It's less than. That actually works. That satisfies that inequality right there. Does that make any sense? All right, so that's the only time when you do that. When you divide by a negative, or sometimes you might multiply by a negative to get rid of something. Like if you had a fraction, right, you multiplied by a negative. If you divide or multiply by a negative, right, not a positive, because right here we divided by a positive and everything was fine, wasn't it? But when you divide or multiply by a negative, that's when you change the direction of your inequality. Okay, I don't say take the inverse, I don't say flip it, I say change the direction of the inequality, because that's exactly what you're doing, right? This was pointing to the right, now it's pointing where? To the left. Does that make sense? You learned that before, didn't you? On inequalities? All right, but it's the one thing that you have to remember that a lot of students forget. It's really the only thing that's different. Everything else is exactly the same, except when you get to that point where you have to divide or multiply by a negative number. Just dividing by a number doesn't change it. Just multiplying by a number doesn't change it. It's when you divide by what? A negative number is when you change the direction of the inequality. All right, have I beat that into the ground long enough? I think so. Let's go up here and let's solve this problem right here. So what are we going to do? We're going to subtract a 5 from both sides, and that gives us, that cancels out. Do I change the direction of the inequality by subtracting? No. I can add and subtract all day long, and I keep the direction of the inequality going in the same way. All right. So what do I get? I get negative 3x is greater than negative 12. And what do we do now? Got to get x by itself, so we divide by a negative 3. Does that sound familiar? Yes? No? Anybody talking to me? Okay. So you divide by negative 3. So what goes on here? That cancels out, so I have x, but I divided by a negative. What do I do with that inequality when I divide by a negative? I have to flip it or change the direction. Let's say that, okay? Change the direction of the inequality. Negative 12 over negative 3 is positive 4, so that's your answer right there. Let's just see. Let's just for fun, just pick a number that's less than 4, plug it back into our original just to see if it actually works. Pick a really easy number, like a 1. Right, that's less than 4, isn't it? Put a 1 in here. Negative 3 times 1 is what? Negative 3. Plus 5 is 3. Is 3 greater than negative 7? Sure it is. Positive 3. Any positive number is greater than a negative. 2, that's what I said. 2. It's 2 greater than negative 7. Yeah, it still works, right? So 2 is greater than negative 7, and so it works, doesn't it? I could pick numbers all day long that are less than 4, and it's going to make that thing work. As soon as I pick a number that's greater than 4, guess what? It's not going to work. What if I picked 4 itself? Negative 3 times 4 is what? Negative 12. Negative 12 plus 5 is negative 7. Is negative 7 greater than negative 7? No, it's not. So I can't even pick 4, can I? I can only pick numbers that are what? Less than 4. Not or equal to.
No,
Just...
I mean, 4 would only work if it was less than or equal to 4. Wouldn't it?
This wouldn't work if it was equal to 4. If x was equal to 4.
No, like, you can only... Yeah.
If this was or equal to, you could put or equal to right here. Yeah, but it's not, though. All right? There are times where it will be, though. Right? Where you have the or equal. You know about that, right? Where it's or equal to. So, but that's not one of our situations. Now, one thing that they ask you to do here, and you're going to moan and groan to this, but this is easy stuff. All right? Don't get caught into this mode of thinking. As soon as I say this word, you're like, oh, goodness, I hate this. Because that's the reaction I usually get from this. All right? Just like that, too. And, no, it's not. Well, you could have fractions in here. But we're actually let's do this. What was our answer? X? Yes, I am going to say that. See, told you got that reaction. I told you not to react that way, and you still react that way. It's just a gut reaction, isn't it? But this is easy baby graph, okay? This is baby graph. Look. So we do a little number line, right? Do a little number line. X is greater than 4. Now look, a lot of people do this. They set up their graphs. They always put 0 in the middle. You don't always have to put 0 in the middle, right? If it says x is less than 4, so what? Here's what I usually do. I usually put a few of these things on here. Okay? X is less than 4, so 4 will be over here, won't it? Okay? Or I'll put a 5 here. 4, 3, 2, 1, 0. Doesn't that make more sense than always starting at 0? You don't always have to start with 0 in the middle. You can do it like this. Since I'm going to the left, I'm going to have more numbers to the left than I would to the right. Okay? So this is what we did in the old days. I'm going to show you a little bit of a different way that they do in the book. Okay? It's not much different, just a little bit. In the old days, it's just less than. There's no or equal here. So do you remember what kind of a circle we put it for? It would be an open circle, wouldn't it? But then we shade in, right? We shade in everything where? To the left. So we would shade in, go from 4, and we'd shade in everything to the left. Like, look at that. Now that's shading, isn't it? Isn't that nice? So, let's make this back into 1 point again. All right, does that make sense? All right, that's what that is. Now, with one little difference. They don't put the open circle on here. For some reason, not even sure why, to tell you the truth. Let's make this a little bit bigger. 3. What they do is they put like a parentheses thingy, like this. All right? So instead of an open circle, it's a parentheses. No, we're doing the parentheses. I didn't give you a choice. Who gave you a choice? All right? I'm showing you how we're doing it here. All right?
Why did it change that?
Because they're going to show you a different way of, they call it interval notation. We'll talk more about it in the next lesson. Let's just worry right now that if it's an open circle, you just put a parentheses. Okay? If it was closed, you put a bracket. All right? So if it said, let's do this. Let's do a different color. Watch this. Got about 1 minute left, maybe. 1 second left. How about that? So look, if it was, let's say x is less than or equal to 4. 1, 2. Don't leave yet. 4, 3, 2, 1, 0. Watch. What would you do on this? You'd put a bracket. So watch. At 4, you'd put a bracket like that, and then you would shade everything to the left. So the old days, remember what we did? We put a closed circle, but now we're going to put a bracket, because tomorrow what we're going to do is we're going to show you this thing called interval notation, and you'll see what I'm talking about then. All right, but that's basically all you have to do today. Solve for x, and then graph the thing on your number line. It's that easy.